Hello, my name is Florian Ruppel. I'm a solution architect at SmartPiot. And in the next 45 minutes, I want to present to you GraphQL Extended, which is an extension to the GraphQL specification. I'm very excited to give this talk and to share with you our hard work over the last year, where we introduced this technology at a large client. It is mainly used for exposing resources created by microservices in form of a dynamic GraphQL gateway. What it all means, I will cover in the next slides, and we will also go over a few demos. So please join me on this ride and let's just see what this is all about. First of all, this project has already a website which comes in form of a small tool and some documentation that is available. You can visit this website via its GitHub organization at graphql-extended.github.io. The screenshot below shows the basic form of the tool, which allows you to input your GraphQL extended schema on the left hand side as an input and see what's the output on the right hand side. But hold on a minute, let's first get some essentials out there. How did we end up at GraphQL? What advantage does it give us? And what is GraphQL about? If we look at the evolution of backend architectures, we of course start with our classic monolith. We have a single service, the backend. Maybe this backend already renders some websites. Maybe this backend already exposes some APIs. But this backend really comes in form of, let's say, one giant code base that's just sitting on a big machine. Now in the recent years, there was quite some run about the whole containerization, cloud native applications and microservices. As a consequence, of course, we also want to follow such patterns if the problem we face fits perfectly to this pattern. Now here, some client does not need only to communicate with one service, but with lots of services. That means potentially many different URLs, potentially many different ways for authentication. Of course, there are means to solve this, and by far the most popular one is to have a centralized gateway to a quite scattered backend landscape. So here we see that the whole dispatching is actually done by the gateway. Still, our client, in this case the front end here, has to know about all these services. Why? Because even though we are not directly communicating with them, we need to know what kind of resources are available and how the APIs are structured. In the end, this gateway is only forwarding the requests. So essentially, a lot of, well, let's say common duties can be performed by this gateway, like for instance, have some per request billing or performing an authentication or even session to token based authentication translation. All these kinds of tasks could be handled by the gateway, but nevertheless, in the end, the gateway is just some kind of a proxy, essentially forwarding a request that was given to it from the front end to some target service. And that means we still have the same limitations. We still need to know what kind of services are available, to know their resources, to know their structure, to know their specification. We also can only perform one request at a time. That means if I want the resources from two different services, I need to basically create two different requests. Now, how does GraphQL help us to mitigate all these problems? Well, first of all, what is GraphQL? It is a specification for a query language on top of REST, which means at the end this is a standard REST endpoint that we get. However, just a single one that has a very special shape for its resource. Actually, what we perform here is a post request, and what we will get back is the result of this post request. This is perfect in compliance with what we call RESTful. Nevertheless, what's inside the resource that we post to the service running GraphQL is essentially kind of a query structure. It is a well-formed JSON, but it contains another specification inside in the values of the JSON properties. This is the GraphQL query specification. Now, to resolve these queries, our server needs to also to run something. This is the so-called GraphQL schema. And essentially, what it does is, it gives us conventions and a structure for a large backend API. Using the schema, we are fully typed. So we have an ability to communicate to clients what is available. This all is already implied within GraphQL. As a consequence, clients can now selectively use the available backend resources. This is a great advantage compared to REST, where we can also of course do the same, but we would need to invent all this on our own. So GraphQL already gives us the boundary conditions that are needed for actually running a system using selective usage of available backend resources. And yes, of course there are many .NET implementations for both consuming GraphQL in form of a client, having for instance the query transport already handled very well, but also having the server being ready to resolve GraphQL queries. So that means being able to write a schema, being able to resolve an incoming query to functions that selectively select the backend resources that are needed. My favorite one is hot chocolate. We will come to that at the end of the talk when we also see what GQLX, the GraphQL extended, can bring to the table. But let's first focus a little bit on why flexible APIs with GraphQL are so powerful. Let's take this simple call as an example. Here we just designed a REST interface for a customer resource. We also have some query parameters, for instance, to allow something like pagination for selectively just getting a part of the whole data set out there. Also, we specified here some kind of a filter. Now what that filter does, we don't say. Let's see how this call would look like with GraphQL. Instead of getting some resource, we now need to post to some endpoint. This endpoint can be freely chosen. Let's just say it's the root of our service. We just post a standard JSON document where we need to have keys that follow the GraphQL specification. One of the very special keys is query. It allows us to just write some query. The text content now of this special property is indeed a GraphQL query. And in this case, we are querying the customer's resource. We give it some parameters, start, limit, and also here a filter. For readability, I inserted new lines. In reality, you can of course transport \n characters, but in the end, of course, you need to have a valid JSON document. Now, one of the differences to the standard RESTful approach is that while we implemented for this special resource customers some parameters like start, limit, and filter, such as the query parameter counterparts, we can already out of the box select what we want to transport for each of these customers. We only are interested in ID, name, and size. There could be 10, 20, or 50 more fields. We would actually discard them in the answer. This saves us bytes in our transport. Of course, we could invent some kind of selection field and let's say have it also as a query parameter in our RESTful API. But then this would need some documentation and we would need to implement this field selection also. And the problem only goes worse. Now in this case, ID, name, and size may be primitive types, but in reality, they could be quite complicated objects with a nested structure, and GraphQL actually allows us to also pick from this nested structure what we are interested in. Coming up with a similar, or let's say remotely powerful syntax just on top of REST is a quite difficult endeavor. So GraphQL gives us these abilities out of the box. There are no more unnecessary transports. We can directly communicate what we are interested in. Let's look at another example. We just saw I want to get our customers. What if there are two more things? Let's say I also want to get some clients and users. Well, in GraphQL I can write that. And here you see my query does not only request customers with potential parameters, but also clients and users. And for all of them, I can make also selections of the fields I want to get. So in the end, instead of having, in this case, 3 requests, I have only a single one. GraphQL server will do the rest and will send it to the client accordingly. This is all in one request. Another example. In my RESTful approach, I may want to have the start and the limit somehow being determined by the user. Now I can of course always do some kind of string concatenation, but then we all know what can happen. There can be some kind of attacks on this vector, where people just say, oh, okay, I know they are concatenating strings. If it's just a free field input, I can just try to manipulate that. It will be sent to the server, so, or stored in some database or whatever, and then of course it can have quite negative impact. So we always need to do some kind of sanitization for this. Well, with GraphQL that was sorted out from the beginning, I can write a query syntax like this, where I actually say I have my own kind of query which defines 2 parameters. One is called start, another one is called limit, both of type integer. And actually then I use these variables to do the actual query in GraphQL. Now, inserting specific values is done via another property called variables, where we just have an object defining all the variable values. So very simple syntax, and once this reaches the GraphQL engine on the server, this can be properly checked and sanitized there. So this is a problem I don't have to care about. GraphQL will ensure that type is correct and that these variables can be used accordingly. All I need to do is specify it as variables and not just in my query string. Again, I don't need to do anything here. It's just free, and there is no need for me to construct a safe URL or the JSON payload. Now, how does it look to create a GraphQL schema? It looks like the following example. Here I define two queries, one for posts and one for an offer. I also define a mutation which will actually trigger a change in the backend. And the key thing is that everything needs to be typed. So for instance, my posts query needs to tell, okay, what does it return? It's an array of post. And this array of post needs to know, of course, what a post is. So we look at it and we see, yes, it has three fields: ID, which is an integer in this case, and will always be there; title, which may be missing and is a string; and offer, which is of type offer. And so we also need to define this. In the end, we can also document this using the hash bank. And this whole schema is completely read in by GraphQL and then used in an introspection endpoint where we can actually always, like let's say an out-of-the-box Swagger documentation, get to know what's available and how can we use it. So the good thing about it is there is really no need to generate anything, because since it's fully typed, GraphQL knows the full story. Also, there is no unnecessary documentation needed, because GraphQL is purely resource focused. There are no technical details whatsoever involved here. It's all about the types and therefore all about the resources. So really great. This is not only used for documentation, but of course is also used by GraphQL to make proper input validation. That's only one direction. The output is of course also validated. So if GraphQL sees, okay, for the offer query I should return an offer, however, for some reason our resolver does not work correctly, we will not get back something fishy, but rather no offer. So we will just set undefined back, more or less. Alright, so I hope that gives you at least an idea what GraphQL is about. Let's see what now GraphQL gateway solves that a standard API gateway doesn't. Let's see some of the challenges and potential solutions. First, let's discuss the closed versus open environment. So you remember this diagram from the start of the talk, where we have a client communicating with a microservice backend via an API gateway. This is rather nice, and it only worked because we have a closed environment behind this. That means every access to a service needs to go via the gateway. The nice thing about it is that we can assume certain things without compromising security. If this is all in its own private network and the only thing that is exposed to the outside is our gateway, we can actually really give the gateway some common tasks, like for instance already performing the authentication check, or some billing engine, or some rate limitations, or many different useful things, and the services can purely concentrate on delivering their kind of resources. Now, if we break that up for some reason, for instance, we have multiple clients. They may be front-end based, but they may also be other services, and we want to communicate at least with, let's say, a subset of the services. Then we need to break up this assumption and have an open environment in the end. Here the gateway can be considered just another service, but in the end, common tasks like, let's say, authentication checks or rate limitation need to be done by every kind of service. This of course introduces some redundancies, not only on the development level, but of course also on the service execution level, where an authorization check is not only done on the first service that hits, but also on the subsequent services that are hit. Now, having these kind of services exposed can of course be very beneficial from a business perspective. Each service can have its own access control and can be developed by a team completely independent from another service. It can be even hosted in a completely different environment. So there are certainly aspects that make this rather appealing. Again, the standard way here is we could also have some service sitting somewhere. This service could dynamically enter from another environment. And while the former case only described the one way where external services want to communicate now with the green boxes here, it can also be the other way around. That there is another service coming, hosted somewhere else, that actually our gateway should connect to. We can think about this like some kind of service discovery, where we dynamically want to say, okay, great, the set of our services is not fixed, it will always grow, and when it grows, I want the new resources to be available on the gateway. So the gateway does not statically reflect the backend, but is a dynamic gateway. And of course this also works if you are inside a closed environment. There it works even better, at least from a security perspective. Now, how can we solve some of these issues? A service registry can actually perform the heavy duty of collecting all the available services. As a consequence, our gateway does not need to know which services are available and could only go against this service registry, which is there to collect only the available services. And of course their structure and available resources from these structures. Now, as I said, this does not only work in a closed environment, but it can also work in an open environment. The only difficulty here is, of course, how to keep this registry secure, such that not any kind of external service can register, only the ones we want to allow. In the best case, we don't need to do much here. There's an implicit way to achieve this. Now, this was a small introduction to actually the backend that we created, the large client. This client is one of the world's leaders in optics, and it is split in various strategic business units, which have their own customers, which have their own processes, and which have their own development teams, such that an open environment had to be created, special rules, and the approach was exactly as described. You needed a service discovery that works with these boundary conditions and that allows registrations of services, the resources, to be exposed in a gateway. So how can we make this work? There are multiple ways. The simple way is of course very easy. Each service needs to expose GraphQL. Sounds rather easy, right? But there is one drawback. How can we ensure that the exposed GraphQL schema does not clash? If we introduce certain queries, then the names of these queries may collide from one service to the other. Furthermore, every service now of course is forced to implement GraphQL if it makes sense or not. Especially for services that are really purely REST based, that have already existed, this is quite a burden. So instead, one could say, yes, there is a middle way. You just have your, well, let's say RESTful API, or not so RESTful. Then all you need to do when you register is potentially via some automatic transformation to build up a JSON document describing how GraphQL resources map to your RESTful endpoints. This mapping then is used in the GraphQL gateway to create something which is called a resolver, and resolvers are responsible for actually knowing from a certain resource demand to how to actually obtain this resource. So think about it like this. You want our customers, and our customers sit on some special service. So we actually would need to go via a HTTP request from our gateway to the customer service to get the customers. Alternatively, of course, if the customers are directly accessible from some kind of database, the resolver would say, okay, I know how to reach, for instance, this MongoDB instance and get the requested documents from there. So a resolver can be anything from mock data generator to an HTTP requester to a SQL connection, executing SQL queries, for instance. Now, this is the limited way because, yes, first of all, we need to have something in our services, but second, the resolvers that can be constructed this way, they are limited. I mean, by convention at the end, they can be rather simple, so we would just make a skeleton of the request that we take, where we say this is the method, this is the URL, these are the parameters, but then again, noting all the resources, it would involve a lot of work to define this JSON DSL, and in the end it would potentially look like a hybrid of a JSON schema plus some abstract syntax tree. So therefore, if we say already, oh, this goes more in the direction of a programming language, why not use GraphQL directly? And this is what I would call the flexible way. So our resolvers are actually defined via a JavaScript DSL, which means it's just JavaScript at the end of the day, plus some custom functions, plus of course some boundary conditions. Like for instance, we are not allowed to throw, or we are not allowed to eval, or to use certain JavaScript APIs that are known to be rather insecure. Furthermore, we get abilities like unit testing out of the box, because at the end, such a DSL would introduce custom functions, for instance, for performing a GET request, and that can be very easily mocked away. So we can actually test this quite simple. We can have local test instance without any trouble, because it would actually define the whole GraphQL experience without actually having to maintain a GraphQL service or server on each of our services. And of course, we can still have the same kind of automatic or convenience, like for instance, having a swagger to this special kind of notation. So you may think now, what is he even talking about? How does this look like? What is this GQLX? I mean, so far we only talked about microservices, a little bit the evolution of backend services, and we've only briefly mentioned what GraphQL Extended is about, and it was only about GraphQL so far. So before we come to that, let's first see how such a service may now look like. So our service starts, and this is, let's say, a very classical RESTful service, but make no mistake here, it could be really anything. So it then needs to register our service registration. We then have to do some kind of a handshake with the registration service, it is really secure, and that we get, for instance, our GraphQL schema, if we want to register there, properly set up. This is all done in form of a metadata exchange. There is also other data that may be exchanged here, like our name and version of our service, some ID. And finally, if we are done with this registration, our gateway gets the updated schema, which is already here outlined as GQLX. And we will soon see what GQLX, which is short for GraphQL Extended, really means. Now, when a request comes in, it is resolved on the gateway. This resolution involves, what kind of resource is this? Where was it defined? Where do I need to go to? So let's say we resolve this incoming request, and we say, okay, one of these pieces needs to be derived from making a call to our service. Well, we just go there now. This already uses the information that was registered during the service registration. So what is this GQLX about that makes all this magic happening and the decoupling really possible? Here is what it looks like. Again, this is a GraphQL schema, and on the first glance it doesn't look different than the schema with beforehand. We have types like foo, and then we have queries like this foo's query with parameters like name. But then there is one new thing in there, which is the block after we specified the return value type. This block is a resolver block, and this is a new feature brought in by GQLX. What we write inside this resolver block is a standard JavaScript expression, and it's just one expression. Yes, you can have arrow functions like shown here, but then these arrow functions can have standard bodies. So we also have the possibility here to have statements like you would know from standard JavaScript, like if, while, and for statements even in there. We have all that. But again, by nature, this thing has only a single expression in the resolver block. And while we can also use things like map and filter, we have also special functions available. As a matter of fact, you can just define what functions are available, but out of the box, GQLX specifies that there are 5 default functions. One of them is get. There are also ones like post, put, delete. And the get function is actually an asynchronous function, like all the others I just mentioned. Still, the code here looks very synchronous, right? So we say let's get first, then obviously we get back an array, so we filter this one, we only want the active entries, and then we map these active entries. And we see we can also use more modern ECMAScript syntax here. So it's the full JavaScript language. There are some restrictions, as I mentioned. They are for sandboxing reasons. Cool. So this is then later fully sandboxed, so we can run this on our gateway, because we can be sure when we have a legit service that we trust anyway, but if there is really something bad happening due to some reason in the specification coming from the service, nothing bad can happen. It cannot penetrate our security from the inside. Yes, it could do a fishy request somewhere, and yes, that could not be so nice, but in the end, there is just flexibility in here, there is no security hole. Plus it gives you some cool and powerful synchronous API. Think about it like an implicit await everywhere. And everywhere being in quotes, because it only inserted there where you actually need it. With that being said, let's just see how it looks like on the web page, but also in an editor like VS Code. How can we write GQLX? Let's start on our web page, GraphQL-extended.github.io. As already mentioned, on the left side, we can just place some valid GraphQL. So let's just start a simple type foo that has one property called ID of type ID. This is just a simple string, but it already transports the meaning of being unique. Now I can also add a query for this. Let's just say foos, which gives us many foos. We already see that a schema was created out of this. This looks at the moment like the input. Now I write an resolver block, and I already can see there is something missing, unexpected token, because we need some kind of expression. Let's say we go to some server at API foo and just return this. Maybe it comes as an object and there will be a key items. Now the schema is still the same. We just strip out this resolver block, but in the resolvers we see there is a new query foos, and we can inspect what the generated code would look like. So we await this actually, and then we return the items. This is really what's happening, and it doesn't matter if it's as simple as this or if it's a little bit more complicated, like this schema that I just inserted, that contains fairly simple resolvers, like this one for mutation called create subscription, but also for some resolvers that use very custom logic. Again, from the schema, all the resolver blocks are stripped out, and then we get all the resolvers with their generated code, which for the enter chat room here would look quite complicated, of course, but at the end of the day is of the same meaning as the GraphQL we wrote. And we can even look at this code in VS Code using the GraphQL extended language server protocol, which gives us not only syntax highlighting but also code completion, refactoring and more elaborate error messages. It's all sensitive to the GQLX file endings, but you can always switch to the selected language mode. This is the same file, and you can see the syntax highlighting, which is different from the GraphQL part than to the JavaScript part. Now that we've seen how we can write GQLX, let's just get a little bit further. We were also .NET developers, and even though the previously described microservice backend had a mixed landscape, one of the technologies we used was .NET Core. So how do we use it with ASP.NET Core projects? Well, in multiple ways. For us, the most important one was the use of GQLX for validation. Yes, that sounds trivial. Let's see what this is all about in a sample .NET service. Here we have a really small demo service that consists of a single controller, which I called foo controller. It has only one action. This endpoint returns an array of foo model objects. These are fairly simple. They just consist of an ID and a name. Now, this is a RESTful service, but let's say we want to include this service in our microservice backend, and we want to expose it via our GraphQL gateway. What do we need to do? We only need to describe all the logic via GQLX, right? So let's do this. Here we use this. We even extended that model, but ignore this for now. Let's now say, yes, we have the type foo, we have ID, we have name, and we have a new resource called foos. So far so good. But we want to make sure that this schema is actually valid. What should we do? Well, there are multiple things we can do. And actually, we got a small library that covers all these cases. We can write a simple unit test that just asserts that this schema is indeed valid. As a matter of fact, we already wrote such a unit test. Let's just run it again. Oop. How does this test look like? Well, very simple. We just create a new GQLX compiler, give it the schema file, and in the end validate it. That's it. We can also, of course, give the raw string source to this compiler or do something else. Now, let's pretend we wrote a mistake, for instance in our resolver block, just a trailing comma here. Let's run the test again. And this time it failed. So apparently this validation is sound and helps us. Now if we don't trust our own unit tests, we can do several other things. We can of course include such a test on the startup of our service and disallow our API from running. We could also, of course, have some more integration-like tests. And they could also be built up again on GQLX tooling. Once we started our API, we see it correctly serves some entries. Now these GUIDs are for demo purposes just randomly generated, so they will change over time. But what doesn't change is the names here. Now how can we assert that our GQLX logic goes to the right endpoint? Well, we could either use the .NET library to actually run some integration tests, or we could also do some exploratory testing using the GQLX command line tooling. Using this command, we can just run a simple GraphQL server that serves the GQLX and uses our localhost development environment as the target. And the nice thing about it is that we directly see our schema and we can go against it, and we successfully assert that everything's running as it should be. So with this, we can actually perform a validation of a GQLX schema specification, and we wouldn't even start the service or successfully pass the build pipeline, just thanks to unit tests and the validation of our GraphQL extended .NET library. But that's not all we can do. Let's also have another demo using .NET Core powered web application that acts as a GQLX gateway. Again, we have a simple demo service that we equipped with the popular hot chocolate solution for providing a GraphQL server. Let's start this service to see what it is all about. As we can see, the service has a standard RESTful API, but that's not what we are after. We are actually after the GraphQL that is exposed. We have already an iGraphQL instance here, and if we look, we have already one interesting resource called hello, and that just gives us back a string called world. So how did we reach this? Very easily, we just added it via add GraphQL in our services and use GraphQL in our application builder. So in the end, this is just the standard plain hot chocolate API or ASP.NET Core middleware that is applied here. Nice. So how to go from there? Well, at the moment this is still the standard GraphQL, which is split between our schema and the bindings. What if we could simply change this and say, let's add GraphQL extended. Let's say yes, we want to return the string world here, and then not have this binding, such that everything is just in the single block. Now, this GraphQLX middleware can give us a little bit more on top of hot chocolate. It can dynamically swap out these queries, and the queries can come in from different sources as well. So it can be a standard GraphQL gateway, but for now, let's look at this. Okay, so back here, and yeah, we get the same result. We didn't expect anything else. So in the end, what the GraphQL with the extension gives us is the automatic introduction of the resolver, which is quite nice to have it in one place. And that's all we need to do. So, as I said, it's really easy to get into the air with this and to have your own kind of gateway that, again, can also perform a lot of middleware tasks Nevertheless, important thing is you can have this dynamic registration and update of GraphQL snippets that come already with a resolver specification. Let's see a sample benchmarking application, how this behaves as compared to standard GraphQL. Great. So obviously we don't have to worry about performance. We also don't have to worry about the security so much. What's on the roadmap? What's next for GraphQL Extended? Well, as I said, it's running in production. We had a go live last year in April. Since then, of course, internally we rolled out some updates, but we're mainly focused on seeing that it runs stable, that it fulfills our needs. The next steps, and that's why also I'm very happy that I could give this talk to you, is we want to work on really building a foundation around this, to see if other people are interested in using it. And if so, of course, to improve what we can do with our introspections, to improve our editing experience in VS Code mainly, but via the language server protocol in other editors as well. To invest more in tooling. Here we of course we have a start, but it's almost always just tailored for our needs. Let's see what the community thinks, and let's invest here. And finally, of course, the goal should be to have a really stable, API stable, 1.0 release of the whole thing, where the specification is complete. And we also ensure some backward compatibility, such that when we want to do further extensions to our extension, we are not breaking, right? Should be already in there. So what did I present? I hope you found it interesting. This is a solution for really dynamic GraphQL gateway, so you don't need to just specify the resources up front and it's there. No, they really flow in. It supports open environments as well, not only closed environments. All you need is a common service registry. You can use, of course, open source solutions for this. Essentially what we brought into the standard GraphQL is a lightweight JavaScript based domain specific language, which allows you to define the resolver directly within the GraphQL schema. And yeah, we have support for .NET, Node.js, we have editor support, we have some tooling out there. There's always more to come. We want also to provide something for Java. At the moment, we use some solution internally, but it is not really well thought out. And I think we can also bring a little bit more languages and frameworks in here. And we would really welcome any kind of contributions. So let us think. Let us know what you think about it, and if you're interested and if you find some issue or want to extend this, feel free to join our GitHub organization and collaborate. Would be awesome. Without further ado, thanks, and have a great conference.